Okay, this is the notes page on solving rational equations and inequalities, and this is part 2 where we're going to solve rational inequalities. It's on the back of the notes page for rational equations. Very, very important that you understand that if you like that multiply through by the LCD method, you cannot do it with inequalities. If you have one of these, that's not the same as an equal sign. So you have to do this a different way. You're stuck with the fractions. You are stuck with the fractions. So even though this looks very similar, it's not. What we're going to do is we're going to set this inequality to 0. So I'm going to move these two terms over here to the left. Okay, so step 1, that's x over 2 minus 5 over x plus 1 minus 4 over 1. And I'm just going to make them all fractions, is greater than or equal to 0. Now, these minuses, I'm worried about them, so I'm going to change them to plus and negative. Okay, so step 2, we want to combine fractions into one fractions. So that means I'm going to ask a different question. I'm going to ask the question, what does this fraction have in its denominator that this one needs? And again, these are not the same at all. If this were an x, they wouldn't be the same. If this were a 1, they wouldn't be the same. They're completely different. So what I'm going to do is I'm going to multiply by what I call a convenient form of 1. All right, by asking myself, what does this have in its denominator that this one needs? Well, this one has an x plus 1, so this needs an x plus 1. Well, I can't just multiply the bottom one by x plus 1, the bottom of the fraction. I have to multiply the top and the bottom. Also, what does this one have that this one needs? Well, this one just has a 1, so it doesn't need it. Okay, plus negative 5 over x plus 1, same thing. What does this one have in its denominator that this one needs? Well, this has a 2, so this one's going to need a 2, so I have to multiply by 2 over 2. This is legal because 2 over 2 is 1. Anything times 1 is that thing. This is still 1. All right, plus negative 4 over 1. What does this one need? All right, this one had a 2, so this one needs a 2 over 2. This one had an x plus 1, totally different than the 1, so this needs an x plus 1. So you have to multiply this plus a negative 4 over 1 by 2 times x plus 1, and then we have greater than or equal to 0. Don't forget that. You got to have a left side and a right side. Okay, so now what you want to do is you want to multiply all of that together. All right, but you want to always leave the denominator factored. Leave the denominator factored. There's no need to multiply out the denominator. We got to multiply out the numerator. Okay, so what's going to happen is this is x times x plus 1. That's x squared plus x over 2 times x plus 1 plus a negative 10 over 2 times x plus 1. I'm just leaving this factored. Plus, this is a negative 8, so that's negative 8x minus 8. Can't tell you how many times that negative does not get distributed to that positive. That's why I changed the signs there. That is the most common of errors. Okay, negative 8x minus 8 over 2 times x plus 1 is greater than or equal to 0. Now I might skip that step later because you can see they all have a common denominator. Okay, so now I'm just going to add the numerator together, and I have an x squared term, and then I have an x and a negative 8x, so that's negative 7x. Then I have a negative 10 and a negative 8, that's negative 18. All of that over 2 times x plus 1 is greater than or equal to 0. So all of that to get step 2 done. I have combined the fractions into one fraction. Alright, now I'm going to find the critical points, the zeros. And there are two types of zeros. Okay, the numerator has some zeros, but I can't find the zeros until I factor. So intermediate step, or actually it's step 3, you got to factor if you can. So this is going to factor into x and x. Factors of 18, 1 and 18, 2 and 9, 3 and 6. Which one subtract to be 7? That's minus 9 plus 2 over 2 times x plus 1. Okay. So now that it's factored, I can find the zeros. The zeros from the numerator, x minus 9 equals 0, x plus 2 equals 0, that's x equals 9, and x equals negative 2. These are the numbers that if you plugged in, you would get 0. Okay? And since it's greater than or equal to 0, they're going to be included. Okay? But then there's also the denominator. X plus 1 cannot equal 0 because it's in the denominator. So x cannot equal negative 1, but it's still what we call a critical point. It's a point that you want to graph. Okay, so that's the next step. We found both types of our zeros. We want to draw a number line, and we want to put all three of these on here. This is where either it equals 0 or it cannot equal 0. Okay, so we've got three critical points, 4 regions. And now it's time to do sign analysis. Okay, so first of all, negative 1, it can't be negative 1. So the 0 from the denominator is always going to be a whole. But from the numerator, these might be colored in and they might be open. It depends on this. If it says greater than or equal to, then it can equal negative 2 or it can equal 9. Alright, so now what we're going to do is sign analysis. So we're going to take this factored rational inequality and we're going to test some values. So if I put negative 3 in, it's just like we used to do. We're going to put negative 3 into that first binomial, that's negative 12 or negative. Negative 3 in that second one is negative 1 or negative. Over a positive 2 times negative 3 plus 1 is a negative. So you have 3 negatives. That's going to give you a negative. A negative times a negative is a positive. Positive divided by a negative is a negative. So every number to the left of negative 2 is going to give you a negative value. Okay, this is a little tricky because we only have a fraction in between negative 2 and negative 1. I'll try negative 1.5. But it's not that bad because I don't really care about actual numbers. I just want to see if they're positive or negative. Negative 1.5 minus 9 is negative. Negative 1.5 plus 2, oh, 2's bigger, so that's positive. We've got a positive 2, and then negative 1.5 plus 1, oh, that's a negative. So you have 2 negatives, so that's a positive. Okay, and I'm putting that 2 down because what if it were negative 2? Then it would make a big difference in your sign analysis, so I don't want you to forget it. Alright, next region we can put 0 in. So if we put 0 in there, 0 minus 9 is a negative. 0 plus 2 is a positive. You have a positive 2. 0 plus 1 is a positive. You should have 1 negative, so that whole region is negative. Try 10. 10 minus 9 is a positive. 10 plus 2 is a positive. You have a positive 2, and 10 plus 1 is a positive, so this whole region is positive. Now just like before, we want greater than 0, so we're going to shade the plus regions. And then the last step, put it in interval notation. So this is bracket negative 2, comma negative 1, parentheses union, bracket 9 to infinity. These are all the solutions. Okay, so let's try example 2. Alright, so the steps are set the inequality to 0, done. Step 2, combine to one fraction. It's actually done. Step 3, factor if you need to. So yeah, you can factor the numerator. That's 2 times x plus 3 over x minus 2 is less than 0. Okay, step 4, find the critical points. You do that by setting the numerator 0, factor equal to 0. So x equals negative 3. And then you also set the denominator factor not equal to 0. X is not equal to 2. But these are going to show up on the number line. Okay, even though x is not going to equal 2, that's a sign change happens there. So we need to put negative 3 down and 2 down. And I love it I love to write down this inequality right here because this is what I'm going to analyze. And this is the rational inequality I'm going to use. So I'm going to pick a test number. I'm going to put negative 4 in here. That's 2 times a negative, because negative 4 plus 3 is negative, over negative 4 minus 2 is also a negative. You have 2 negatives, so this whole region is positive right here. If we try 0, that's 2 times a positive over a negative, so that's a negative. If we try 3 and put it in there, that's 2 times a positive over a positive, which is a positive. So we now know how everything behaves. I skipped this. Let's talk about what should be here and here. Can't ever be 2, so that's an open circle. And this time, this doesn't say less than or equal to, it just said less than. This is where it equals 0, so this doesn't get included this time. And then we want all the numbers that are less than 0, all the y values. So the y values that are negative are right here. So these x values give you a negative value. So we put it in interval notation, that's parentheses negative 3 comma 2. Alright, take a look at example 3. Step 1, you have to get this to 0. So we're going to have to move this 3 over. So that's x minus 3 over x plus 1 minus 3 over 1 is greater than or equal to 0. Don't forget to write that part down. So it looked easy, but it's not as easy as example 2. Alright, I would do plus a negative here. I don't want you to lose that negative, so I'm going to plus a negative. That puts that negative right by that 3. Alright, and now again, this might be new for some people. This is the hard part. You need to get a common denominator. You can't multiply out by it. So the question you're going to ask is, what does this one have in its denominator that this one needs? And the answer to that is nothing, because there's just a 1 there. However, what does this one have in its denominator that that one needs? And the answer is not x. The answer is this is a completely different thing. This one needs an x plus 1 factor. So I have to be honest, I have to be legal, so I can only multiply by a convenient form of 1. I have to multiply the top and the bottom by x plus 1. Okay, don't forget to distribute that negative. That's a very common error. Alright, so we get x minus 3 over x plus 1 plus a negative 3x minus 3 over x plus 1. So our objective is combining this to one fraction. So now I have a common denominator. I'm just going to add like terms. So x plus a negative 3x is negative 2x. Negative 3 plus a negative 3 is negative 6 over x plus 1. It's greater than or equal to 0. So we have our one fraction, but we have to try to factor and actually look at factors, the numerator factors. I'm going to move it up here. Negative 2 comes out. So negative 2 times x, negative 6 divided by negative 2 is positive 3. Okay, so now everything is factored. Okay, so now I can find my critical points. From the numerator, I get that x is equal to negative 3. That comes from x plus 3. And that's going to be a colored in whole because it's equal to. From the denominator, I get that x cannot equal negative 1. Okay, because that would give you 0 in the bottom of a fraction. So if I draw a number line, make sure you put them in the right order. Negative 3, negative 1, colored in circle, open circle, greater than or equal to. Now we do test points. So if I try negative 4, watch this. See that negative? That's going to affect your sign. Negative 2. Negative 4 plus 1 is a negative over negative 4 plus 1. That's a negative. How many negatives are there this time? Not 2, but 3. So that's a negative. If I put in negative 2 here, negative 2, that negative with that 2 is really important to not forget. The negative 2 plus 3 is a positive. Negative 2 plus 1 is a negative. How many negatives is that? That's 2 negatives. A negative divided by a negative is a positive. And then if I try 0 here, negative 2, positive 3 over positive 1. So we have one negative, that's a negative. And we want the numbers that are greater than or equal to 0. So that would be here. So that answer is bracket -3, comma, -1. Okay, so in the lab manual you have practice problems, page 144 currently. If you need to just go to the table of contents, look at solving rational equations. Do a couple of each, because remember, equations you can multiply through by the LCD. Okay, so let's go back to that and see if you can remember. So if I do number 1 plus a negative, I have the power of the equal sign. Just remember Miss Mills saying that. The power of the equal sign. You can do more with an equal sign. I can multiply through and get rid of these fractions. So I'm going to multiply by the LCD. I need a t and I need a t plus 3. I'm going to multiply these terms here by t times t plus 3. And whatever I do on one side, I have to do on the other. And that's legal. That's an algebraically legal step. Basically, I multiplied this side by t plus 3 and I distributed it. That's why it's getting multiplied to all three terms. And then you can cross cancel. You're left with 2t minus 4t minus 12 equals 4t squared plus 12t. No more fractions. All right. Set it to 0, that gives you 4t squared. Then 12t plus 4t is 16t. And then move that minus, looks like I forgot about that 2t, so that's easy to fix. That's 14t. And then that minus 12 comes over here plus 12. Alright, so now I can solve that. Let's pull a 2 out, so that's 2 squared plus 7t plus 6. Let's see if it factors. Put a 2 here and a t there. Factors of 6, 1 and 6, 2 and 3. Outer and inner terms, and they have to add to be 7, and I can see that's going to be working if I put a 2t plus 3 and a t plus 2. So set those equal to 0. T equals -3/2 and t equals -2. Now with this rational equations, don't forget to check. I typically, when I'm getting involved in the problem, I'll forget to do the restrictions until the end. It doesn't really matter. Now I see that t can't be -3, right? And neither of those answers is -3. T also can't be 0, and neither of those answers are 0. So those are my solutions. Okay, if you look on the previous page, page 142 right now, you've got rational inequalities. And they're harder because you can't clear the fractions. You're stuck with the fraction. You want to get one fraction. So here we have to set it to 0. Plus a -1/1 is greater than 0. Then we have to multiply by convenient forms of 1. What does this one have in its denominator that that one needs? Nothing. 1/1. What does this one have in its denominator that that one needs? X plus 2 over x plus 2. And I don't need to multiply the other side because I'm multiplying by 1. It's legal to multiply by 1. So that's going to give me 2x minus 1. Don't forget to distribute that negative, minus x minus 2 over the common denominator x plus 2. And that's going to give me x minus 3 over x plus 2 is greater than 0. So x equals 3 is one critical point, and x cannot equal -2 is another critical point. So we're going to have an open hole here and an open hole there because it doesn't say equal to. And if I check my signs, a -3 on top gives you a negative, a -3 on the bottom gives you a negative. This is positive. Let's put 0 in, that's a negative over a positive, that's going to give you a negative. Put in 4, that's going to be a positive over a positive, you get a positive. And we want positives. We want greater than or equal, greater than 0. So interval notation, negative infinity to negative 2, parentheses, union, 3 to infinity. Just did 2 from the lab manual really quickly, but just wanted to get you in the flow of solving a rational equation is much different than solving a rational inequality. Equations, you can use the multiply through by the LCD method. Whatever you do on one side, do on the other. Completely legal. Inequalities, you have to keep the fraction, so you're going to multiply by convenient forms of 1. And you ask yourself, what does that one have that this one needs? Just practice. Biggest issue people have, aside from the hard stuff about fractions, is the negative. So please be careful about distributing the negative to the second term.